Okay, and so I want you, we haven't done anything with complex numbers yet, but that will be kind of a thing that we'll be dealing with a little bit in the next chapter. Okay, all right. Like I say, I assume that you know nothing, but I know some of you know a lot, and some of you have been out of school for about 10 years. Okay, all right. Does the square root of -4 have an answer? Not a real answer, because you can't take a number, multiply it by itself, and get a negative, right? Okay, so there is no negative number by itself that would give you a negative number. You can't do that. Complex numbers, the idea came from René Descartes, and this equation right here was thought for hundreds of years. Most people thought, well, that just doesn't have a solution. Well, it does have a solution. And the idea with this is, if you take a number and square it, you're going to get a positive, right? And you can't take a positive number plus 1 and get 0. So if you go back before Descartes' time, you would just think that's nonsense. Okay, well, what Descartes did is he imagined that there was a new type of number system. Okay, that's why we call it an imaginary number. So what he decided to do is just to call the square root of -1 I. And so let's pretend like there's a number. Now, to me, what's interesting about this is, you know, he didn't have any idea of what it would mean or anything. And it turns out imaginary numbers show up a lot in lots of areas. They show up in electronics a lot. They show up in quantum physics quite a bit. Nobody would have known that. And the thing is, they're solutions of equations. So we kind of came up with this number system, and it turned out that it was kind of had all these uses to it. Okay, and that seems weird to students, but it's always been that way. There was a time when human beings didn't know what a negative number was, but they discovered that they probably ought to use negative numbers and fractions and stuff like that. So we've continually looked at different types of things. I like this stupid cartoon right here. It says, "Why are you turning in a blank sheet of paper?" What does that say? Because my answers are imaginary. Ha ha ha. Math joke. I think it's funny. Okay. All right. Okay, let's just kind of review this stuff right here. So first of all, and this stuff right here is stuff you just do really quickly. Hopefully you've got a good background for it, so we won't have to spend all that much time on that. So the idea with this is it's not a real solution. What you do, and you can just write your answer, but what you're doing is you're breaking it up like that. You're doing square root of -1 times 9, okay? But what is the square root of -1? That's I. That's what Descartes said, is I'm just going to call that I, and then the square root of 9, of course, is 3. So the answer to that problem is we're going to write that as 3I, okay? Now, you don't have to go through that. You're going to, as a student, you're just going to know this. Like, for instance, what's the square root of -49? 7I, okay? That's what it is. So you just write, you know it's an imaginary number, and you do that. Okay, this one, again, you can do in your head. You could use your calculator. That number's big. I think that's 16. So that would just be I times 16. So that would be 16I like that. Okay, so if the root comes out as a perfect square, you're just going to have the I in there. Okay, these next two kind of work like this. Again, you can write this as square root of -1 times square root of 162. So you would have I times square root of 162. Now, you do not have to write that step out. I just want to show you the reasoning behind that. So if you see a problem like that, you can automatically go there. You just know it's an imaginary number. Okay? So now with 162, well, it's like we've done with radicals anyway. We want to go through and see if we can break this up. So let's see, 162. You can play with that on your calculator a little bit. That would be 162 times 81. Is 81 a significant number? Yeah, it's a perfect square. So what you would want to do is write this as I times square root of 81 times square root of 2 like that. So that would become 9. So you'd have 9I times the square root of 2. Okay, and that's how that goes. Okay? So that's kind of, shouldn't be a big deal because we've already spent a lot of time on radicals. Okay, this one goes like this now. Now this time you just have a negative in front of the radical. So that doesn't have any bearing on anything. It just means it's a negative number. Okay, you would write that as -I times the square root of 288, like that. It's just a negative number, okay? Then if you do 288, let's see, that divides by 2, that's 144. Is 144 a cool number, a perfect square? Okay. Yeah, that's 12 times 12. So you would write that as negative I square root of 144 times square root of 2. So you'd end up having negative 12I times square root of 2 like that. Okay, and that's it. So that's the first thing on imaginary numbers. You want to know what they are and how you work with radicals, okay? And a lot of the basic stuff in this section is going to be just kind of an overall way that you work with imaginary numbers. Okay, next thing I want to show you is if you're multiplying imaginary numbers, there's a certain way you got to do this. Okay, this is wrong. Like if you had square root of negative 2 times square root of negative 3, those are two imaginary numbers, right? You do not want to multiply it together and put it under the same radical. You can't do that. You have to take a totally different approach on that. Because if you did that, you would get square root of 6, and that's not the answer to the problem. What you do instead is you write this as I root 2 and I root 3. Okay, and then what you would do from there is I times I is I to the second. Then you're allowed to do 2 times 3 under the radical because 2 and 3 are real numbers. So the thing on that is you're not allowed to multiply those numbers that way. So what I'd end up having is I squared. The other thing that you want to make sure you remember is I squared is negative 1. Do you know why? There you go, good. Yeah, okay, I is equal square root of negative 1. Well, if you square both sides, what happens? Radical goes away. That's actually by definition. A mathematician, we decided that's a definition. And then the whole entire complex number system is built around what I and I squared are, okay? So if you finish this problem, that would be negative 1 times square root of 6. So that's just negative square root of 6. So what happens, is kind of weird, is you could think of that as a positive imaginary number times a positive imaginary number is a negative real number. That's kind of weird, but that's the way it works. In imaginary numbers, a positive times a positive is a negative real number. Okay? That's how it works out. It's got a totally different set of rules on it. Okay? All right, next problem. Let's see. Is it okay for me to do that? Yes or no? No, okay. Yeah, you never do that, okay? I see students do that all the time. Instead, what you do is you write this as I times square root of 5 times I times square root of 3. That will give you I squared times square root of 15. So what's the answer? What's I squared? I squared is negative 1, right? So what you would get is negative square root of 15 like that. That's the correct way to do that, okay? All right. This next one, there's two ways you could do this. You could, if you wanted to, just put them together and say I root 10 times I root 4. But what is the square root of negative 4? That's 2i. You could go ahead and change that to 2i, and that's what I'm going to do. So I'm just going to write this as the square root of 10. I'm going to write that as I times square root of 10. And then this, I'm going to write that as 2i. Okay? Now what you'd have is you would multiply these together, and that would give you 2i to the second times square root of 10. And then again, I squared is what? Negative 1. So you write this as 2 times negative 1 root 10. So the solution of that would be negative 2 root 10. Okay? Again, it's the same thing. This is a positive imaginary number times a positive imaginary number is a negative real number. That's the way it works out. Okay? Okay, this one looks like about the same thing. Let's just do one more of these. So that would be I root 6 times 3i. Okay, that would be 3i to the second times square root of 6. So you can just write that, and you can do that in your head. It's just when you see an I squared, that's going to change that to negative. Okay? Everybody solid on what I've done so far? Okay? The basics of imaginary numbers are fairly simple. And we're doing this because when we start solving equations, equations are going to have complex number answers to them. Okay, let's go to division here and addition and subtraction. I just want to get through the real basic things here tonight. So this you have to do the same way. So if you're doing division, you would have to write that as I times square root of 50. Then you would have to write the bottom as I times square root of 10. Okay? So now what you can do is, well, the i's divide out. Okay, you can just take those out, take your i's out. That sounds weird. So those cross out. And then what you'd end up doing, now you can put 50 and 10 under a radical because they're real numbers. You could not do this problem this way, although you would get the right answer just by luck. You're not supposed to do that. So what we'd end up having is it looks like that would just be square root of 5. Okay, that's it. Okay, that's the idea. Okay, all right, next one we'll do the same way. We write that as I times square root of 48. And then we say I times square root of 6. I's divide out, cross your I's out. That's going to be 48 over 6. Okay, then that's square root of 8. Okay, and then what do you do with square root of 8? 4 times 2. You break it up, okay, because you've got a real number on there. So you would say square root of 4 times square root of 2. Therefore, you would have 2 times square root of 2 like that, okay? And that's it. That's the real basic things that you do with imaginary numbers, okay? I think that'll wrap us up tonight, okay? All right, you guys keeping up? Okay, fast-paced, isn't it? I can go.